As we look at the principles of how we produce an EMF, we're going to look at this phenomenon known as electromagnetic induction. And you might have heard about a bloke named Faraday, and he did a whole lot of experiments that led the way, along with some other guys, into us being able to produce electricity. So what did he use? He used a magnet and a coil of wire, and almost by accident discovered that it wasn't when they were stationary that anything was happening, but when there was motion, he created an EMF, or a voltage. And you can see, if you look very closely, that a few turns of wire with a weak magnet is actually causing the needle to move. So if we then substitute our weak magnet, still with a coil with a few turns, to a strong magnet, you'll notice now you can actually see the meter move. Same number of coils of wire, just a stronger magnet. And if I increase the speed, we'll tend to see a greater swing on the needle. That swing on the needle is indicating AC, because as the direction of current flow changes, so the direction of motion changes, so the direction of the EMF changes. Under the rules, we'll have a look now and see what happens when we increase the number of coils. We've got a few here. We're going to connect in one with a whole lot more turns. So I'll just change coils of wire so I don't get any interference between the two coils. Now, again, coil of wire with a lot of turns, weak magnet, and even with fairly slow motion, you've got a noticeable movement on the meter. We're producing an EMF. I'll now change to a strong magnet, still moving fairly slowly, and we've got quite substantial movement on our needle. So we've increased the EMF that we're producing. We've increased the voltage. And if this was a complete circuit, we'd have current flow. And really that's what's driving the meter. What happens if I increase the speed then? If I go slowly, we get a small movement on the needle. But if I go quite quickly, I'm increasing my output. So the three factors we've used are number of turns of wire, strength of the magnet, and also the rate of relative motion. And these are the three foundational things we build on to create a charging system, and it's how the alternator works. Thanks, guys.